All right, everyone. Review session number 2 for the exam. I recorded all the new questions from yesterday, since yesterday from the Google Doc. I noticed that there were some addition. I recorded up to about 10 a.m. This morning, but there were a few more questions on the Google Doc. I'm not too sure if I can really get to them. I may not be able to. So this is what I would suggest. So when I talk about any other relevant questions, if you think your questions are relevant, you can simply just speak up or simply type on the chat. I'll try to see if I can address them at the same time. Otherwise, if we're lucky, if we got some remaining time before 5 p.m., I might be able to take some extra. All right? Okay, so let's now start. Okay. The first one, again, I kind of reorganized the order of the question just to flow better. Okay. The first one here, it's about the Singleton patterns from Ring. And let's read the question together. Over here, for the Singleton design pattern, so would the design pattern still be satisfied if we get rid of the data access class and also add expanded and also once inside the data class? Okay. I believe what Ring was suggesting was, so rather than having this particular, rather than having this particular class, right, we're going to put data, which is a once routine, and also maybe possibly this invariant as well. We're going to put, remember the data access class itself is also expanded, right? So how can we know that it's expanded from the diagram, right? You can see over here, this is the diamond shape from the client side, right? We talked about it in the lecture. So what Ring was suggesting was, is it possible to say, number one, we can put, maybe we can move, change the data class itself to be expanded, so that we don't really have to initialize the data whenever we declare that, right? That's one concern, one aspect. Another one is, what if we simply put also the data over here, right? Think about, we're expanding this particular class over here, and then we'll simply put data, and then simply data itself. And then it will be a once routine, and etc. All right, over here. All right, imagine that it's a short answer question to all of you. Okay, I would say depending on how you are asked, your answer can be slightly different. Okay, so there are two ways you might be asked. For example, if this was the question. So let's talk about one by one, and you can type on the chat or speak up. We can discuss, and I can give you some feedback. So number one, so you can see what the change I'm trying to make, right? So basically, I delete this class over here, and I simply move the data routine into over here, and it's still once. Okay, so now number one, will we still have the Singleton access to data, right? Of course, here we talk about data, but in general, it can be any objects which for which you want to get Singleton access. That's question number one. And question number two, which I'll write in green. Is this a good design? Are we compromising any design principles by collapsing data access and also data into the same class? Is this a good design? All right, we got number one and number two. Yeah, I'll just open the floor for any feedback. Anyone who want to try. This could potentially be a short answer question or short essay question for exam. So if you want to practice, feel free. I'll just wait to see if anybody wants to speak up.
Professor?
Yeah?
I think it will still work, but it will be violating a number of design choice, for example, single choice principle and cohesion principle, because we will have the things which is only necessary in one aspect, but we'll have it added to the whole class in a way.
Okay, Pavel, what you're saying is you believe number one is still going to work. That one I would tend to agree with you, because we still have the once routine. As long as we have the once routine, we are guaranteed we're always being returned the same object reference. So I think for number one, it's not a problem. So number one, it will still work. Okay, so that one I would tend to agree with you. I would put a check over here, right? Number one is yes. The reason that it works is because we still have the once keyword over here. In some way, it will make sure starting from the second and onwards call to the same routine is going to give you the same object reference, right? That's the exactly essence for once keyword. So now, what about the second one over here? Is this a good design? You mentioned about cohesion and also single choice principle. Can you explain again why this will violate single choice principle?
I think on a second thought I'll take it back because single choice means you only change in one place. Yeah. I think it will still, but cohesion would definitely valid because it have an additional feature which is only needed for specific parts, but we're gonna have to call the whole class essentially to be expanding. Like, yeah.
Yeah. Okay. So so over here, I would say single choice principle over here doesn't seem to be violated simply because we don't seem to see any duplicates of code. If you actually got some duplicates in multiple places, of course, that would be a good indication that you're violating single choice principle. But cohesion, as you pointed out, I'll tend to agree. And the reason that this will violate cohesion principle is because, so remember we talk about separation of concern, right? You don't, for a single class, you don't really want to put features of different purposes into the single class. Let me just make it more clear to you. You can think about this guy over here, this part here, is really about the data itself, basically, right? So this one here is really about the data. And then this part over here, which we just expanded, right? We just kind of extend this particular, this part over here, somehow it's not coherent with the data class itself. This is more about the access. So you can see these two are simply different purposes. So that will violate cohesion. Okay, so that will be my feedback over here. Okay, so depends on how you are asked about this question here. So after this particular change, we have only one single class called data, which serve two purposes. One is about the data itself, and also the other one is about the data access. If you put these two together, programmatically, it might still work. It may not be a problem. However, if you talk about whether or not it's a good design, it's not a good design. And if you, this is not new to you actually. If you look back to the lecture, when we talk about the how you would do it in the Java case, right? We talk about in the Java case when you actually have a single class where you got some static attributes over there, and also you try to play with the constructor being private. In that case, it will still work programmatically, but it will definitely violate cohesion. So that's exactly what we are having over here, right? So that's why I said when you try to review the lecture materials for the exam, since the exam is supposed to be comprehensive, so you really want to tend to think. So also one of the Google Doc question was, whenever you study a particular design pattern, do you need to know why the previous design attempts wouldn't work? My answer is yes. In some way, it's they are equally important. You really want to know what's the thinking process for you to see whether a design is actually ideal or not, right? Okay, let me take a look at any feedback that might be worth mentioning, okay? Yeah, something about export status over here. Yeah, so I think I wouldn't worry too much about the discussion for export status over here, but I think the main thing is when we are adding this particular data over here, right? So this data here should not be exported to anything, should not be restricted to anything else, because this is the only way for external clients to get access to the Singleton access, right?
Sorry, Professor, I have a question.
Othek, yes.
For the data routine, if you put it into an expanded class, does that even make sense? Because the expanded class doesn't actually return an address, right? So would that even work?
Okay, that's a very good point. Something I didn't really talk about. So this might be another question here. So I think I would say to simplify our discussion here, I would say, how about we simply get rid of this expanded over here? To say we only try to collapse these two, this data here, just to extend that. So remember the only reason that we actually wanted to have expanded, okay, for expanded, very briefly, right? The reason that we want to have it for the data access is because whenever we declare DA of type, let's say data access, in that case, you can directly say DA.data without having to initialize it. As I said also in the lecture and then possibly in the Q&A as well, So the expanded class itself does not contribute to the singleton access itself. It's only for the convenience of calling the data routine. So let's not complicate this particular scenario. Let's say all we want to do is we really don't want to add the expanded over here. We just want to add the data over here. Okay. Okay, you're right. If we simply also make the data class also expanded, you're right. Somehow it's not reference type anymore. So that means we don't have aliasing anymore. So you're right. It might be causing trouble. But let's not get there. It might be a little bit too complicated. All right. Okay, is that reasonable to you?
Yeah, thank you.
Okay, good. I think it's good to clarify. Okay, good. Robbie was asking something about over here. Robbie was suggesting some syntax over here to say, let me just write it out just to clarify. For example, expanded, which is a keyword, and then you say data, which is a routine name, which returns data. And then you put once, right? That's what Robbie was suggesting. However, this one here, let me clarify. Expanded keyword is only applicable to a class. It's not applicable to a routine. So this does not even compile. So we don't even need to think about it. Okay, so that's what Robbie just suggested. All right. Guys, I got one more question about the singleton pattern. I will go over that quickly. That's from one of your quizzes. Once after that, you can follow up with any question that might be related to expanded type or maybe singleton pattern. That'll be the best timing to ask. Okay, let me just go on to the second one. So this is from one of your previous quizzes. It's from Patheth. Okay, so now, you know what? Actually, since this is kind of random, right? So and also I didn't include the answer over here. So why don't we take this chance as a short answer question or short essay question? Okay, the question goes like this. And Patheth, you can try. Or maybe somebody else you can try. I can also try to correct your answer. Let me just give you the context. Let's say this is an attempt to really implement a singleton design pattern. Okay, so we got a bank data, and also we got a bank data access. It seems to us cohesion design principle is satisfied because we do have a separation concern, right? So that's not an issue. But you got to pay attention to how exactly things are being implemented. I'll let you read it. And then this is a test class where we simply try to make sure, we want to make sure we got some singleton access BDA, right? And then we want to make sure every time we call D, it's going to return some data 1, data 2, and they should be the same objects. So that's why we're using the equal sign to compare the address, right? So now, let's say this is not even a multiple choice. I simply give you this design. Can you tell me, number one, is the design appropriate? Number two, if that's not appropriate, why not? Well, what's going to happen at the runtime? Okay, anybody? This could be a nice example to also review the singleton pattern because you have to go, you have to think through all the necessary ingredients for the singleton design pattern. All that being said, if the design is not appropriate, sure, but you got to justify, right? Eric, result in test class should fail because the bank data access doesn't use a once routine. Okay, so hopefully everybody's having a sharp eyes like Eric. Basically, I'm not sure if you noticed this over here. This guy over here, so this is basically the access routine that was supposed to return, that we're supposed to implement. We want to make sure only the first call to the routine is going to give you a brand new objects, but for all the subsequent call, it's going to give you the same object reference. So this one apparently is wrong, and there should be once instead. Okay, so now apparently we can see number one, not appropriate design. Because the routine returns distinct objects upon every call, upon each call. However, I wonder, let's still look at this class over here. is there anything else that's wrong about implementing the design pattern? Sorry, about the singleton design pattern. Okay, if you think about one's routine, okay, that's good. Okay, I can see Chauvin. He noticed that the invariance over here doesn't seem to be right. Over here, right? So now, over here, that's right. But of course, hopefully you guys are not just memorizing the invariant. That's not the way to go, right? Let's try to understand that, okay? So now, if you believe, first of all, we know that the invariant is not appropriate. However, if that's not appropriate, so then remember, well, first of all, when is the invariant checked? Every time you call in the D. Okay, so first of all, this invariant is checked. Each call after the D, right? After we're calling D. Okay, so that means we're going to check the invariance over here, but also we're going to check the invariance over here, right? So these are the two places we're going to check the invariance. So now, is the invariant, even though if the invariance is actually wrong, are we going to get an invariant violation? So that's the second follow-up questions.
Professor?
Give me one moment. Yeah, let me just write it down and I'll take your input. Just give me one moment. So invariant is actually wrong. Okay, over here, that's actually wrong. But will we get invariant violation? So that's a follow-up question I have for you. Yeah, input question.
So this is the case when it is once, right? Not do.
We talk about do. We'll still talk about do. So the once is something you should have done, but let's not say we have done that. So it's something you want to keep in mind. That's something you should have done. Let's say we still have the do over here. And we know that the do is not going to return the same singleton object reference upon each call. So that we know, that's number one. And number two, we notice that the invariant over here is supposed to check like every call to the same routine is going to give us the same reference. That's why the correct answer should be using equal. That's the correct answer. But currently it's only using tilde, which means it's really meant to compare object contents rather than object references. So that's inappropriate. But here's my question. We know that this particular class invariant is actually wrong, but are we going to get any class invariance violation when we check at the runtime after these two calls? Are we going to get? Okay, Tempeh say no, and then Chauvin say no, Jiahao say no, and Ofek say yes. Okay, Ofek, why? Why would you get a class invariant violation?
So can I, okay. So I'm just assuming that the is equal is not being redefined, so it goes to the default.
Okay, yeah, maybe,
just compares the
sure,
object's
no problem.
address.
Okay, I should have clarified that, so it's not fair to actually ask you. So let's say we assume that is equal has been redefined properly in the data class. So would you change your answer?
Okay, so in that case, it won't be violated.
It won't be violated. Okay, so Oved, would you like to explain why it wouldn't be violated?
Well, assuming the interest rate is the only attribute and it's being initialized in the constructor correctly, the same way as every other object, then both objects will have the same value for the attributes. So it'll be the same and it will return true.
Yeah, very good. Okay, so I think it's really important, but don't worry, if in the exam, if you're asked this particular question here, you can simply assume that whatever you're getting is all you get, basically, right? So you can definitely make the assumption that, so in this case, we're making the assumption is equal is already redefined, okay? Okay, so now we will not get a class invariant violation. And the reason is, let me just repeat, basically, Ofei just explained. It is because every time when we are calling D over here, we're basically just calling this particular part over here for the implementation, which in turn calls the constructor from the data class. And you can see the constructor over here always initially set the interest rate to be 1.24. Okay, so that means after this particular call, it's going to give you an after this, you're going to check this particular invariant, right? And let me just zoom in a little bit. How exactly do you check this particular invariance? think about green one is one call to the D, and the pink one is just another call to the same routine. Calling that every time is just going to return a brand new object by calling make, which will simply give you a data object with interest rate 1.04. So it's always going to be the same. It's going to be, okay, let me just be more precise. When I do D over here, it's basically going to create an object over here of type data. And then we got interest rate. And then that one is going to give you 1.24, sorry, 1.04. All right. And then the second time we try to call this in the invariance context is just going to give you another distinct object. However, now the data over here is basically also interest rate and also 1.04, right? We're calling the same constructor. However, assuming that the is equal is actually has been redefined properly, which means it will compare the interest rate. And then we're only using tilde. So that means these two objects will be considered as object equal. But if you use the equal sign, which should be the correct way of doing it, you will get class invariant violation. All right? Hopefully there's no confusion there. All right, so now let's just get to the final question. That's basically the quiz question itself. Knowing that there are actually two things that are actually wrong for this particular design. Number one is do rather than once. Number two is tilde rather than equal. All right. So now let's say we follow the wrong solution over here, right? If you follow the wrong solution, so that means these two lines will just be okay. But now data one and data two, you can think about is basically getting two data objects over here, even though they are contents equal using tilde. But now the test itself is actually going to use the equal sign over here, right? So now if you try to compare these two, right? If you try to compare this, so one way to think about is different objects simply, right? If you use an equal sign over here, it's going to give you false. So that's why the result will be set to false. So eventually you will get a failing test. So there's no contra violation, no invariant violation, but you're going to fail the test just because the Boolean result is set to false. So Patheth, so that's your questions. So are you okay with this explanation here?
Professor?
Go ahead.
Yeah, I wanted to ask, for example, if there is once instead of do, and
hypothetically, okay, you say once rather than do, yeah?
Yeah, and invariant being the same. So the test would obviously pass, but would the singleton be implemented?
So, okay, so now you are asking, okay, first of all, are you okay with this explanation so far?
Yes, yes.
Yeah, okay. I just want to make sure because you were the original student asking this question. Good. So you're asking another question. Let's say hypothetically, this is another new question. Okay, why don't I put it on the new slides so everybody can take advantage of that? Give me one moment. Let's now consider another version of the question over here. Let's say the question goes like this. So now let's say the design correctly say once, but incorrectly say tilde. That's your question, right? So what's your thoughts? Patheth? So what's your answer then?
So I mean, I was saying that it surely gives you the green bar, but my question was the singleton implemented correctly?
Okay.
My answer is yes, but I wanted to confirm.
So basically, yeah. So basically, what's going to happen is, so now this particular equal sign over here is going to be true, right? Because now we are really returning the same objects each time. However, the invariant over here, even though there wouldn't be any invariant violation at the runtime. However, I would claim to say this invariant is too weak. Too weak in the sense that if you're only checking that if the two separate calls to D are really returning objects of the same contents, it's not really doing anything towards the towards checking if the singleton pattern has been implemented correctly. Because in order to really check if the singleton pattern has been implemented correctly, you have to check about object reference, right? So now it's too weak. Equal sign should have been used. You're just not checking the right thing, even though you don't have the violation. Make sense to you?
Yes, Professor.
Okay,
but
good.
If the question is like the singleton is implemented or not, so what can we say?
Yeah, so basically,
Can
okay,
we
so what you
it?
got to say is, number one, let's say that's what you're given. You would say, number one, the test will pass, number one. That one we understand. However, we should say that the singleton pattern. Okay, let's be a little bit more careful defining the term over here. Let me define that. Let's say this part here is the implementation for the singleton pattern, right? That's just the code. Implementation of the singleton pattern. And then let's say this part over here, which we believe is wrong. This part here, let's call it the spec for the specification of the singleton pattern, okay? All right, singleton pattern spec is not correct. Remember when we talk about the setback contract in the very beginning of the semester, having all the contracts pass at the runtime doesn't really mean everything is going well, right? Because you can very easily put a precondition. I'm talking about extreme cases. You can simply put a precondition to be true and also the post condition to be true. In that case, anything the client pass or anything the supplier does, it will just pass. But having all the contracts pass without any violation doesn't mean anything in this case, right? So in general, having no contract violation shouldn't be a good sign of a good design. Okay, that's my point. Okay, it's not correct. Okay, I would say if the implementation was not done correctly. For example, let's say somehow, so here we are lucky, the supplier actually did something that's actually correct. But what if they did something incorrectly? For example, they simply used the do rather than once. Then invariant violation will not occur. But it's expected to occur. Yeah, sorry, just running out of space, but it's expected to occur. So do you, Pathit, are you okay with this?
Yes, Professor.
Okay, good. All right. All right, guys. Any, let me see if there's anything here. Yeah, invariant 2 week. Okay. Cedric actually said it correctly. And then something about, yeah, okay, just give me one moment. Yeah, I'll get to you. Annis was mentioning about something about compare objects. So compare objects is not really necessary over here. We only use compare objects when we talk about like a collection, right? It's not applicable over here. And then, okay, yeah, Ofik, go ahead.
So for the tilde, should we always assume that it's been redefined, or would you tell us?
Okay, very good question. I would say, let me just let me think about the exam. Okay, let me say this: if you're given code directly, let's say, sorry, let me just use if you're given code and the code does not show any redefinition for the is equal, in that case you can assume it has not been redefined. Case number one. And in case number two, you also want to search through the description for the question. If the question doesn't really explicitly say the is equal has been redefined, you can assume it has not been. So you can always refer to the question. It should really give you sufficient details about the this implicit assumption.
Okay, thank you.
Okay, yeah.
I have a question.
Yeah, go ahead.
Yes, could you go back to Reem's question, the one before that?
Of course. What about it?
The one before Reem's question.
Oh yeah, sorry, Reem's question. Yeah, it's this one here. Yes.
Yeah.
Yeah, go ahead.
Yes. So if I was thinking like if you have the data under the data class, can't I just use the make method to create a data class?
Actually, they're for different purposes. You can see over here, the make is a command, which does not return anything. On the other hand, the data over here is actually a query, which means any existing clients, whenever they want to get some new, they want to get a singleton access to the objects, they have to call data. They cannot call make. If maybe that's what you were asking.
But like the data creates like the data just runs make, right?
That's correct. That's correct. So yeah, so I didn't really include the details over here, but you're right. So here, this part here will just be the same as this part over here. In order to really get a data, yes, internally you have to call the make, but the clients they would not be able to call make because the make is should only be exported to maybe just the data itself. In this case.
Oh, okay. So it would still have we still have to include an export thing.
I think
for
so.
it to
Yeah,
satisfy
yeah.
Singleton.
It's a good question here. So the reason that the export status over here, possibly it shouldn't be data access anymore. Maybe it should just be data over here. Meaning that only the data class can call the make as a constructor. And also only the data class itself can call the make as a command. And any other client class, they will not be able to. Right?
So
That's,
without
yeah, that's correct,
sorry.
because we want to protect. We definitely want to protect the access to this particular constructor over here. If you do believe you want to have some other mutator with some commands for your data, you can define some public ones, maybe elsewhere. So that'll be outside the pattern.
Okay, so without the data, it doesn't. Without the export status, it doesn't.
You wouldn't. Yeah, you're right. So you can think about part of the. You can also maybe review very quickly the notes from Singleton Pattern. So there are several ingredients over here. Let me just briefly mention. So number one, we have a separation of concern, separate classes to satisfy cohesion. Number one. Number two, in order to really have the singleton objects from different calls to the routine, we need to use the once. And also we have the invariant over here using the reference comparison. So now from data side, we want to make sure the export status over here will restrict only the access class, right? The correct version. Only the data access class can actually call the make, either as a command or as a constructor. We want to protect the access. And then anyone else, I mean any class other than data or data, any class other than data or data access, they have to call only the data, which is itself public, in order to get access to the data, singleton data.
Okay. Yeah.
Okay. Does that answer your question? I hope.
Yeah. Yes,
okay.
It does. Thank you.
Very good. Okay. All right. Good. All right. So now, so that's about the singleton design pattern. Okay, guys, I think that's the only question I have from the Google Docs related to singleton design pattern. Do you have any further questions about singleton?
Yes, sir, about this one.
Yeah, go ahead. Yes, yes.
Am I going first?
Yeah, go ahead, please. Go ahead.
For the current environment, if it's not redefined, and I think it's not gonna be a violation of the environment, right?
You mean over here?
Yeah. If
I think
it's not redefined of.
You mean the is equal is not redefined?
Yeah, I think it's still not gonna be a violation.
I think we're more yeah. So I wouldn't really want to go into the the exact behavior for is equal. So I would say let's make the context very clear over here. Either we use when we use tilde, I think most likely maybe back in 2030 I would have asked you the question between either it's redefined or it's not redefined. But now over here at this level here, I just want to distinguish between either we are using equal or we are using tilde. In the case of using tilde, most likely in your exam, most likely, right? I will tell you explicitly that the is equal will just be redefined properly. So just make the matter a little bit more straightforward.
Okay, thank you.
Mm-hmm.
Makes
yeah.
sense.
Yeah, I tell you what, okay, that's something you don't have to worry about for the exam. From one of our, maybe Jahao, you were there. In one of the previous Q&A sessions there, where we talk about the is equal versus the is equal in IFO versus the equals method in Java. I would say in principle, you can think about they are the same. There are some subtle scenarios where they behave differently, but that subtle differences wouldn't be tested on the exam. You don't have to worry. But I think just when you were doing your labs for the projects, that could be useful. But for the exam, I wouldn't trick you on that, so you don't have to worry. Okay. All right. So something here from Odemy. Expanded class when you compare contents for x equals y, which okay. So I think Odemy is only talking about expanded type. So if you, you can maybe refer to your slides about the expanded type. I just summarize very quickly. Okay. So when we talk about expanded, right? Expanded type. Let's say x and y, they are of expanded type, right? So maybe x and y, they are of some class type, and the class itself is expanded. Well, for example, x and y, they are simply just integer or maybe real number. So now when you say x equals y, for expanded type, this one here is going to compare contents. Right? We'll talk about expanded, not reference. And also, if you do x tilde y, this is also going to compare contents. However, the content, so here, whether or not the is equal is redefined, I would say in principle, it shouldn't make a difference. It shouldn't. However, it could make a subtle difference. By default, okay, you got either case number 1 or case number 2. There's something you can also feel free to try if you want to, okay? So by default, let me just make a little bit more space for myself. By default, let's say if the is equal is not redefined, all attributes are compared. Okay, and number 2, if the is equal may be redefined. May be redefined to compare only certain attributes. Okay, it's either 1 or 2, right? I'm talking about expanded types only. All right, so now from Eric, just to clarify, for now we can just think equal sign would be address comparison, and then tilde will be content comparison. Again, you want to really, well, that's something, whenever you got x equals y over here, right? So now you want to be careful over here. If x and y are reference type, in that case, equal sign simply means address comparison, right? And number 2, if x and y, they are expanded type. In that case, expanded type. Equal sign means content comparison, every attributes. Attribute by attributes, right? On the other hand, let's say this. If you got, let's say, x tilde y, okay, let me move this a little bit upwards. So now when you talk about x tilde y, so also we got 2 cases over here. You know, I think it might be easier to think about if you say x tilde y. So now it really depends. Depends on the redefined version of is equal, if any. Okay, Eric, is that okay? Does that clarify for you? All right. Good, very good. Varam is asking, is it possible we can get access to the to some sample text question on the E-class? What do you mean by that? So you mean some new sample questions, or what do you mean by that?
Hello?
Yeah, hi, yes. What do you mean? I just want to clarify. Yeah.
In the bottom of the eClass website, there's a sample.
Oh, no. Actually, oh, okay. At the bottom, that's only for my testing purpose. You don't have to worry about it.
Oh, okay.
Yeah, sorry for the confusion. So, thanks for bringing that up. For any one of you who actually pay attention to eClass, at the bottom of the page, there's something called like a testing, and then sample textual question. Don't worry about it. It's not supposed to be for exam. It's only for myself to testing. Okay.
Okay.
Yeah. Okay. Good.
Yeah,
Okay. No worries. That's fine. Don't worry about it. Okay.
Okay. Thank you.
All right. Okay, guys. If that's okay, I'm gonna move on. Okay. The next few questions is more about having some proofs for you. Okay, I got 3 examples to talk about. Okay, so we'll talk about them. Let me just start with this. Your fellow students was wondering about the proof tip over here. So this is one proof tip number 1. Number 2. Proof tip number 2 in your correctness proof lecture. And then we basically talk about when either the program S or the post condition R, right? So either here or here. If they involve any array indexing, then the R, the post condition over here, they should be augmented accordingly. When I say augmented, for example, let's say, for example, if somehow I say over here, AI somehow is used as an indexing notation over here. What's going to happen is you have to automatically strengthen the post condition over here by saying, for example, I should be a valid index. So what does it really mean to be a valid index? Unless I say explicitly, you can always assume the indices will start with 1. Okay, that's the assumption we have been making since lab 1. So that means it should be augmented by I should be between 1 and also either A.upper or A.count. Let's say A.count over here. Okay, so that's what the proof tip really means. So you will see several occurrences. For example, I'm going to talk about it today. So for example, 1.1 for your exercise, right? Assuming that you already at least read the question, so I don't need to reintroduce the question itself. So for 1.1, we're talking about how we can establish the looping variance, right? That's the one. So this is basically the precondition, and this is basically the initialization step for the loop. And this part here is the looping variant, right? Because we talk about the looping variant should be established upon the termination of the initialization step. You can see this part here is really the looping variant, the green one. The green one over here, right? We're saying that basically for every index until I-1, for such index j, result so far must be larger than or equal to aj, right? That's the looping variance. That's what you're given in the code itself. However, so now we want to make sure, because AI is actually being used, the index I, so we have to augment the post condition by saying that I should be a valid index. So this is why you will see something like this. Over here, you can see over here, the index we're using over here should also be actually valid. Okay. Okay, hopefully that makes sense to you. We just want to make sure whatever index you're using, we'll put it in this way. Whenever you're doing your proof, 2 things over here. Okay, I'll write it down. 2 scenarios. If you are given, let me just write down a principle for you. If you're given the whole triple to prove, always augment the condition that array indices are valid. Okay, one example would be, you can see we're using array index j over here. You can see that's why we want to make sure j is actually a valid index. Okay, number one. Okay, if you're given a whole triple, you should always try to augment yourself. Okay, if the expression there, if the programming statements or the post condition there actually involve any array indexing expression. Okay, another thing you want to be careful. Okay, now you might be asked to state the whole triple yourself. I'll give you one example. Okay, so let's simply just get to a new page over here, right? So now let's say if I simply got some routine over here, okay, and then let's say we got some input parameters over here, and then I just make it symbolic, right? If you got require, and then you simply got maybe P, okay? So some precondition P. Let me just make it even more, just make it concrete. Require maybe X larger than 4, okay? And then we'll say do ensure and n. And then we simply say over here, maybe you say y is assigned to, I don't know, maybe just z plus x. So assuming that all the variables have been declared already, I just want to show you what I meant by you're supposed to actually formulate the whole triple yourself sometimes, maybe in the exam. So now what about post condition? I would simply say maybe y will be simply larger than or equal to x plus 4, right? This program may or may not be correct, right? So now, for example, let's say if the question itself is to say, given this particular program, we want you to prove or disapprove that the program is actually correct or incorrect, right? Proof or disapprove, the program is correct with respect to its specification. So we know that this part here is the specification, and this part here is the implementation, right? So now, let's say that's the question. So what you're supposed to do is, step number 1, you're going to state the whole triple. And you should make sure the syntax is actually right, which is not complicated. So you would say, okay, Annis, very good. You're thinking ahead of me. That's nice. So x larger than 4, yes, I agree with you. And then y is assigned to z plus x, and then y larger than or equal to x plus 4. Right? That's how you state a whole triple. Okay, that's correct. Okay, and then number 2. So guys, what will be the number 2? What will be the step number 2? So this will be a very likely essay question. I might just give you a program, or maybe I will simply somehow maybe describe some problem maybe in English, in which case you have to identify which part is the precondition and which part is the postcondition, or in which part is the implementation, and then state the whole triple as a first step accordingly before you proceed any further. Okay, so for Jahal, Amir, and also Mohammed, yes, you're right. We should really calculate WP, right? Very good. Calculate WP. The WP, okay, in this case, it would be this part here, right? And when you write WP, you should always make sure the first argument should be a programming statements, z plus x. And then the second part will be the post condition over here. So that'll be y larger than or equal to x plus 4. Okay, and you're gonna follow the equational style as I said yesterday, right? Like that. And yesterday, OFAC was asking how you're supposed to put the various logical symbol, conjunction, disjunction for all exist as the ASCII key by your keyboard. You can refer to yesterday's session. I talked about it, also demonstrated already. Okay. Okay, number 3 will be number 3. Once you calculate WP, whatever it is, you're going to make sure the actual precondition is actually stronger than that, right? I'll talk about termination in just a moment. Give me just one moment, okay? And number 3, this will be x larger than 4 should be implying, okay, get a proof or disapprove. Whatever the result you get, for example, let's say the result you get is exactly over here, right? So this is something over here, just some placeholder. What about termination? About termination. Okay, we know that number 1, program is guaranteed to terminates if there are no loops. Okay, so this one is very obvious for everybody. So what I'm trying to say is, if the program you're given simply contains no loops, it's only maybe conditional, sequential composition, and also variable assignments, these are only 3, right? If there's no loop, so that means termination is guaranteed, in which case you do not have to prove anything about termination. In this case, no need to prove about termination. Okay, that's number 1. What about number 2? Let's say you're given a program with loops. Is likely. Likely means it may or it may not. In that case, you have to prove it formally. It's likely to loop indefinitely, right? Loop forever, let's say. So now in this case, how would you prove it, right? So number 1, so now what kind of contrast do we need in order to prove about a loop will actually terminate eventually? What kind of contrast do we need? Do we need looping variants or do we need something else? Okay, Jiahao, good, variants. Number 1, we need to specify loop variants. And then we actually need 2 conditions to prove, right? I'm going to write it out informally, right? Number 1, the loop variance is actually larger than or equal to 0, right? And also, you want to prove that between iterations, the value of the loop variance will be strictly decreasing, right? So let's say in the pre-states, it should be strictly less than, it should be strictly larger than in the post-states, right? It should be strictly decreasing. That's something we said in the lecture. All right, one question from Annis. So if there's no loop, then termination will be guaranteed. Yes, in this case, you don't need to prove anything about termination. What if we have recursion? You don't have to worry about giving a program that's recursive about proving that. We didn't really cover that. We only talk about some introduction to program correctness. So all you got to do is to make sure you really understand the find max problem that we talked about in the lecture. That's you will be given something around that complexity level. You don't have to worry about recursive program, okay? It's beyond the scope of this class. But for those of you who might be interested in the theoretical foundation for program correctness, you can feel free to contact me. I can give you more references beyond this course. But for the exam, you don't have to worry anything about recursive program. Okay. All right, so that's about, just about augmentation over here, okay? And now I'm going to do some example together with you, okay? And then you can also reveal this. That's also about valid indices, right? Also in the precondition, okay? So what I will do is, as requested by your fellow students, I'm going to prove together with you about 1.1, also part of 1.2. I'll just go over part of the solution that your fellow student was having some trouble understanding. And then there's another proof about loop variance. I'm going to talk about it as well. Let's do the exercise together. Hopefully that can get you better prepared for Sunday. All right. All right. So now the first one. Okay, this one here. Okay. So this is about the proof exercise 1.1, right? It's about establishing the loop invariance, okay? So this part here is the initialization step for the loop for finding the maximum, right? And this part here is the precondition. And this part here is the loop invariance, right? So that's something I assume you already know. From Robbie, how do we type subscript? Good question. So let's say over here, I would say there, let me just talk about over here. Denoting old values in the proofs. Okay, I'll give you two options over here. You can choose whichever you prefer. Number one, let's say you can either say, let's say variable x, right? If you simply say x in the post condition, you're talking about x in the post states. Now, how do you refer to x in the pre states? Either you can simply use the old keyword, like our IFO support. You can either say old x. So this definitely refers to the pre states. So this will be acceptable. You can definitely use it. That's not a problem. On the other hand, you can also use the subscript, which I also use in the slides. So you can simply say x0. So that'll be okay. I know that may not be so easy for you to type subscript using the HTML editor. I would say don't waste your time playing with the HTML editor in eClass. If you just say x0, that'll be okay. Okay. All right. Let me just go back here. How do we establish the loop invariance? Okay. Again. So now we already given this particular Hoare triple, okay? I hope many of you already have given a try, okay? Maybe you get stuck like your fellow students. So your fellow students said they somehow were able to calculate, let's see this. Okay, let me just point it out specifically because your fellow student might be here as well. They said they managed to calculate, well, this is the loop invariance part, right? Somehow after the substitution, they got a dot lower larger than or equal to aj. So this part here, I can tell you that's wrong. You want to be very careful whenever you want to do a substitution. So maybe I'll do it together with you just to clarify. Okay. So is this correct? Not really. Okay. But we're going to see how we can prove it. Okay. So now we can think about step number one has been done for you, right? Remember the several steps we talked about? So step number one, the Hoare triple has been given to you. Let's calculate the WP together, all right? Okay, let me just try to write it. Okay, so now we want to calculate the WP. So this will be I is assigned to a dot lower followed by, if you don't mind, I'm gonna say R rather than result, but when you type, it'll be much easier. R is assigned to AI. Okay? And then we have this particular for all the post condition. I'm gonna just write it. Okay, you're gonna get for all j such that a dot lower less than or equal to j less than or equal to I minus 1. It is the case. You know what? Just to make it a little bit easier, since I know that a dot lower is simply just 1, that's something I can assume. So I'll just put 1 over here, so it can save a little bit of space. Okay. And, oops, sorry. Yeah, that's yeah, bullet points. And then I have 1 less than or equal to j, and j less than or equal to a dot upper. And let me just make this a little bit smaller so I can also copy and paste. And also the result larger than or equal to a j. All right, so that's the post condition I have, right? Just to save me some time, I'm just going to copy this for future use. Yeah, pretty much like how you would do it in the keyboard if you need to copy and paste. Okay, so now what'll be the first step? Apparently we have some sequential composition. So we're gonna say is equal to, it's gonna be equational style of calculation. So we're gonna say the rule of WP. Sequential composition. Okay, so now what we're gonna do is we're gonna say, think about this is the part we want to basically, right? So that'll be intermediate state. So that's the part we want to collapse into a WP. So what we will do is we're going to say WP I is assigned to A dot lower, and then it's going to be another WP, and let me use a different color, WP over here, and then R is assigned to AI. And then it's going to establish, so now I can paste. Okay, over here. Okay, that's the post condition. Sorry, that's looping variance over here. And then I just need a closing one, right? Yeah, just be careful, just kind of think about this, how you would do when you would type on the exam. So now we are done with, we have eliminated all the sequential composition. So what we need to do now is to apply the assignment rule, all right? So now I would suggest we do a little bit, let me jump a little bit, but for you, you should really do step by step. That's just to avoid mistake. WP rule, let's say assignments. Okay, let's think about how you can do it. So now here you're saying that every occurrence of R is going to be replaced by AI, right? Let me just modify directly on the post condition over here, right? Just since I'm running out of space, but you will get plenty of space for your exam. So now I'm going to replace the R over here. That's the only free occurrence over here. Replace that by AI. So now, for whoever was asking the original question here, you can see you put A dot lower over here rather than AI, right? That's already wrong. Okay, so just to remind you over here. Okay, and then we want to do a little bit of, oh, actually, I'll get to this part why this is wrong in just a moment. Okay, that will be the first one. Okay, let me be a little bit lazy here, but I would suggest you don't do this because when you jump step, you might just make a mistake. So what will be the second variable assignment? Every occurrence of I is going to be replaced by A dot lower, right? So where do we have occurrence of I? We have occurrence of I over here, A dot lower, right? It should be replaced by A dot lower. And also, do I have any more I? Let me be careful here. Yeah, we also have over here. Also, the I over here should also be replaced by A dot lower. So now you can see that this particular expression your fellow student had, that's wrong. It should be A at position A dot lower. That's the mistake of substitution. You want to be careful, right? All right. So you're going to get some expression over here. You can write it out. Okay, let me, so this will be whatever result you will get from step number 2. That's whatever you will get, okay? However, this is something I want to ask you about. Is there anything special you have found about this particular looping variance? Let me give you a little bit hints just to save time. Let me use a different color. What's so special about this particular substitution result from here? Anybody? Yeah, it becomes vacuously true, or I like to call trivially true. Because, yeah, so for those of you who pick it up, that's good. So now let me just, that's something also, I think maybe I described it, not in this context, but maybe earlier in the course. Whenever you got for all, universal quantification, if the range you're talking about is simply just empty, in that case, it will just be trivially true. Over here, you can see this can be simplified into 1 less than or equal to j, and here a dot lower minus 1, right? A dot lower is 1, so less than or equal to 0. We know that this part here is simply can be reduced to false. And the theorem you should really know from 1090 is, if you say for all, maybe some x such that you got false. Over here, whatever predicate you have over here, doesn't matter what it is. It will just be reduced to just true. That's something you actually learn from 1090. Okay, empty interval, that's correct. Either empty interval or empty range, basically. All right. Okay, guys, basically, so now that means this part here is simply trivially true. Okay, so that means from step number 2, for this particular 1.1, we got simply just true. So now let's go to step number 3 to finish the proof. So now if I go to step number 3. Step number 3 over here. So now what I want to do is a.count is the precondition, right? A.count implies true. Well, trivially, it's just true. Anything implies true, right? Anything is a subset of the universal set. Okay, so that's how you prove the 1.1, right? I guess maybe you guys either have done the wrong substitution, or you're simply wondering how we can reduce this particular expression here into true. So I'm telling you, you really want to pay attention to the empty range. So here, I-1 is really important. If you actually specify the wrong invariance, for example, if you simply put I rather than I-1, like one of the wrong versions I explained in the lecture, in that case, you wouldn't be able to discharge this particular proof condition, right? You want to be careful. Any question about 1.1 proof? Any question? Jaha was asking, can we write IFF to denote if and only if? That's okay. Or you can simply say equivalence. That's fine too. Or if you say if and only if, that's another way to do it, right? Double-ended implication. Either way. I think they are all they're all used by different logicians, so it should be okay. All right. Any more question about 1.1? About step number 3, sure, from Eric. So Eric, are you okay? Just double check. Are you okay that this entire for all expression for the invariant is can be reduced to true because of empty range? Number 1, are you okay with this? Good. Okay. So for step number 2, we simply calculate the weakest precondition would just be true. And now, in order for the whole triple over here to be a tautology, we want to make sure that the original precondition over here should be stronger than the weakest precondition, basically no weaker. So that's why we want to prove this. And then we are basically A.count, actually, A.count, sorry, larger than 0. I forgot the larger than 0 part, right? A.count larger than 0. And then we know that any predicates implies true. That's simply an axiom, right? Because true is really the weakest predicate you can ever get. So anything should be stronger than that, anything, including true itself. Eric, is that okay? All right. Okay, so that's about 1.1, okay? So now about 1.2, okay? For 1.2 and also another one, okay, I think I want to also save some time for other questions as well. So I'll just point to you where you should want to watch out for, unless you got a very specific question. Okay. A very quick question for Anis. What if we don't really reduce to true? Well, I would say it depends on what you get. So let's say you reduce to something that's simply not equivalent to true. You want to see whether you can prove that this implies that. If you cannot prove it, and you can give some counter examples, so that means you disapprove that the program is actually correct, right? So it's definitely possible. It just happened that the program we gave to you is the correct program. So that's why this can be discharged. What do you mean if we left at the previous step? What do you mean? Well, basically, what if you only, let's say, if you only left out over here, well, apparently you have to know this particular axiom to know that if there's an empty range, then the universal quantification should be true. If you didn't know that, there's no way for you to reduce that to be true. In that case, you wouldn't be able to prove that a.count larger than 0 actually implies this particular predicate. So of course, you need to know that, right? That's kind of the prerequisite to this course, right? And also we reviewed that a few times already. But if you haven't known that, now is the time to know it. All right, good. Okay, let me move on to this part over here. So basically, your fellow students is saying that they are okay with calculating the WP, all the previous step about calculating the WP. So this is about, oh, by the way, this part is about 1.2, okay? Just to give you some context. It's about 1.2, the maintenance of loop invariance. Okay, I'm simply just copy and paste the solution that I gave to you. Okay, I think your fellow students just having some trouble of understanding the logic a bit. I'll just point out to you exactly where you should really pay attention to. Hopefully that will help you understand. Okay, but you can think about this part here is really the WP that we calculate in the previous step, right? This part here. So this is the WP that we calculated in the previous step. You can see your solution sheets, and then this part over here is the basically the precondition in the whole triple, which is, you can see this part is not the case that we are exiting from the loop. Okay, you can let me just put some notes over here. So this means not exiting, not exit. Okay, and also this one here is simply the loop invariant itself, right? If you think about the whole triple. Okay, that's a part that's already done in your lecture and also in the exercise, right? So now I think that, let me just tell you the parts I think you might need some guidance over here, okay? So our goal really is, given that the loop invariance is already the antecedents. So that means in order to prove the consequence, we can assume the antecedents, right? That's what you learned in 1090. And now we want to reuse as many assumptions that we know is already true as much as possible. And we know that this particular loop invariance, let's look at its range. It's from a dot lower until inclusively I minus 1, okay? What we want to prove is inclusively until I, right? It's actually a wider range than I minus 1. So we cannot just use this to prove this, right? Let's understand what the problem is, okay? But what we can do is, we can somehow divide this particular problem over here into two sub-ranges. Okay, so what I meant was, think about the array over here. That might be the visualization you might need over here. Think about this is the array we have. Okay, so let's say this part here is I minus 1, and this is I, right? And this might be the remaining part of the array, simply a.count. And this is basically 1. So what we're doing over here is, you can think about this part here, all the way to I minus 1. This is basically the range for the loop invariance in the pre-states. When pre-iteration, basically, when I say pre-states. They can think about this is the loop invariance before the iteration. Okay, and then you can see now, this part over here is really the loop invariance that's going to be after at the end of the iteration. So this part here is the loop invariance after the iteration. One is in the beginning, the other one is at the end, right? And the difference is we got just this part here that seems to be unknown. Well, that one is simply not covered by the antecedents over here, right? Let's get it straight. What we can do is we can split this particular range into two. range number 1 over here will only cover up to and including I minus 1. And the other one is simply a single value, simply just I. Okay, that's what we're going to get. Let's take a look. And now, when you want to split a range, you can read the theorems over here. So this one is to say, if you got from A the lower all the way to I, what you can do is split into range number 1 until I minus 1. And then we simply just got I as the other one, right? Split all the way to I minus 1, and then we also got I. Okay, hopefully that's okay by you. So now we got I minus 1 here, and then we also got this part over here is simply replacing every occurrence, we're simply just using I over here. Okay, also I here. All right, so now let me just go a little bit further, but that's really something you want to read carefully, okay? And then and then the next step will be, we want to reduce this part over here to be true. Why can this part be reduced to true? We want to look into the antecedents for which we can assume, okay? Let's see this. So this is what we want to prove to be true over here. Let me just say this over here. AI larger than equal to AJ. So what can we do? Basically, one part is you can see the range over here is all the way to I minus 1. In the looping variance that we can assume is also all the way to I minus 1. For that one here, we already got one property here, which is result larger than or equal to AJ, right? There's another antecedent over here, right? We also say AJ is larger than result. If you actually combine these two together, it's quite easy to see. What do we see? Result is strictly, result is actually, did I do anything wrong over here? Okay, let me just erase it quickly. So we got AI larger than result, and result is larger than or equal to AJ. Sorry, I put it wrong order. Let me just do it again. Okay, I'm just trying to make just present it in. It's already set over here in your explanation over here. Let me do it again. Sorry about that. We start with this. AI strictly larger than result. Okay, and then over here, since it has the same range, the upper bound over here, so we can use this as well. So we know that result is larger than or equal to AJ. Notice that it's J, not I. If we combine these two together, what do we get? We get that AI is strictly larger than AJ, right? So that's something we can get. And this will make sure this part here is simply just satisfied, because larger than is simply stronger than, larger than equal to. So we have proved something that's stronger. So that means we can conclude it. So that's why this part here will just be true. Okay. I'm going a little bit faster over here because I assume you already got some familiarity with the proof. So hopefully with the guidance, you will be okay. All right, that's one thing. And then another thing is, you can see, and the next one here, you just have to also use one of the, so we have reduced the left-hand side for the conjunction to be true. What about the right-hand side? The right-hand side over here, you want to prove that, for example, I is strictly I is smaller than or equal to A the upper. How do we prove it, right? That's also included in the antecedent here. So now when you say not the case, I larger than A the upper, it would be equivalent to I is simply less than or equal to A the upper, right? So that one is quite easy. Okay, I should want to write it down for you. Okay, so that's why this part here can just be also reduced to true as well. And AI larger than or equal to AI is also true, right? So everything can be reduced to true. Okay. Yeah, Ove, maybe you just notice my error over there, okay? What is the purpose of AI larger than equal to, well, this is something we have reduced into, so that's why it can be trivially true. But in order to do it, you can see, we can only reach to this particular guy over here if we have done a split into, you can see, we wouldn't be able to do so if we still got the original range from 1 all the way to I. We cannot do it. But now, if you can split the range into from 1 to I minus 1, and also just I. So for this part here, you can trivially say that this will be true. If you didn't split the range, you wouldn't be able to do it. So that's the purpose. So the main lesson for you to learn from the proof technique for 1.2 really is, whenever you are having a big range of the looping variance, in that case, in order for you to reuse its result from the antecedents, you may just want to split the range for the new looping variant, well, I mean, at the end of the iteration. You want to split it into two parts. One can be simply just covered by the original looping variant before the start of the iteration. And then this part over here can be dealt with separately. All right? Of course, if you haven't seen this proof at all before today, you may not be able to follow. I make the assumption that you have somehow have seen the proof, maybe just struggle maybe with some minor points in the proof, so that might help. But hopefully you can just go over the proof yourself and then maybe look at the video again to see if the guidance helps. But any questions about this? Any question? Anyone? I can answer that quickly before I move on to the final one. Anyone? Okay. Okay, next question is from Eric. So this one is about proving the loop variance. That one is from 2.1. Okay, okay, basically Eric was able to apply the WP rule and then somehow just got stuck at some point. So why don't we do it quickly, okay? So what I would do is, let's see this. So I'm just going to do this. So I would say the WP for if AI larger than result, and then result is assigned to AI. And one technique you can use is if the else part is simply missing, so that means all the variables get to retain their original value. So you can think about it would be as if. So otherwise, the result will just be assigned to result. That's how you can think of it, right? Basically, no effects. Okay, so that's the programming part. And then we got over here, A dot upper minus I plus 1 larger than or equal to 0. Right? Basically, that's what we need to do. Okay. Okay, let me skip the reasoning part over here just to save some time. But when you present the proof in the exam, you will have to show the steps yourself. Okay. Let's see this. So since we know this is actually a conditional over here, luckily we don't have any sequential composition. So what we need to do is we need to make sure, let's just do the if branch. If this is true, that means we're going to execute this particular part. Agree? Okay. As an exercise, you should really do, if this is not the case, then you should really execute this part. But for both cases, you must be able to establish the post condition. Okay. Let me just do the if part. So the if part can be reduced into AI larger than R implies.
Sorry, Professor.
Yes, Ovek.
There is actually a sequential part. You just missed it. I is assigned to I plus 1.
Oh, okay. Thank you so much. Yeah, absolutely. Thank you. Yeah, I agree. Yeah, so we do have sequential composition, but as I said, for the illustration to get to the point for you, I may just say the reasoning step maybe verbally. But when you present it, you gotta practice how to do it. Okay, thank you. Good. Yeah, so guys, please watch me closely, right? I might just make a mistake. All right, so now in this case, we're gonna say AI larger than R implies, and then we're going to say the WP. Oh, actually, you know what? Yes, that's correct. So it's going to be You know what? Let me write it a little bit more carefully over here. So this is going to be the WP. So this part will be phase number 1, right? This will be phase number 1. Let me just repeat it one more time, just to avoid as much confusion as possible. Larger than R, and then R is assigned to AI. Otherwise, R is assigned to R. Okay, so now this part over here will be the WP. Let me just write it in a different color. So that'll be the WP for the second phase. I is assigned to I plus 1. And then that'll be the post condition here, right? And then the next one, I can just show you the if branch. A the upper minus I plus 1 minus I plus 1 minus I plus 1 larger than or equal to 0. Okay. Okay, good. So now I'm just going to, how about this part here? Let's try to reduce this part here first. How can we reduce the blue, the light blue WP? We're just going to replace every occurrence of I by I plus 1. So now this particular I over here is going to be replaced by I plus 1. Agree? So that one there, let's see what that should be. Okay, let me just write it down. Here, over here. So this one would just be A the upper minus I minus 1 plus 1. So this would be the this expression here, larger than or equal to 0. Okay, I think so far we are still fine. Okay, so this is the simplification, right? Of course, that's the reasonings. The reason will be we apply the variable assignment WP rule. Having this, so this will be the post condition for this entire if branch to really establish. But now let me show you only the if branch as I promised. So what I will do is I'm just going to show the if branch. So that means AI larger than R implies this will be the body for the branch, right? The WP for R, WP for R is assigned to AI to establish this particular condition here. So that will be A the upper minus I larger than or equal to 0. All right, hopefully so far so good. So now how can we simplify this WP? Again, since it's about variable assignments, so we must apply the variable assignment rule. But now in this case, we are lucky because you can see, well, think about what the rule says. Every occurrence of I, every free occurrence of R should be replaced by AI. Do we have any free occurrence of R over here? We don't. So that means the expression will just remain unchanged as is. Okay. So now what we get is, it will simply just be AI larger than R implies A dot upper minus I larger than or equal to 0. Let me highlight it. So this will be the just for the if branch. So this will be the WP that we'll get. Okay. So now the question is, how do we prove the original precondition over here implies the pink one implies the green? The pink implies the green. It might look a very complicated proof to you, but I can tell you that it's actually quite easy. Okay, why? Let me show you. The reason is we want to think about which one will be useful for us. If you look at the pink one over here, we got basically a conjunction. We got a conjunction here. We can either use this or we can use this, but we don't really have to use both. If you look into the proof tip number 1, okay, I'll refer you to that. So proof tip number 1. In your slides, whenever you're getting a conjunction for your precondition, you can choose to use the one you really need. So let's say I choose to use this one specifically. Let's say I want to use this. So all I can do is I can say, not the case, I larger than A the upper Okay, and then I want to prove that the green one over here. So let me write it down. So it will be AI larger than R, and also implies A dot upper minus I larger than or equal to 0, right? So far so good, okay? But the critical step really is I want to apply the proof tip number 1 to really get rid of this one, which I don't really need. It just distract my attention, maybe distracted your attention as well, but you get stuck. Okay, so now how can we prove that this is a tautology? We're almost there. Basically, I will just use a technique called assuming the antecedents. In order to prove this particular implication, let me say I assume this, I assume this. Can I prove this? If I can, I basically prove about this particular nested implication. So I would say I will assume not the case I larger than A dot upper. And also I can assume A, I larger than R. Okay, actually, this one is not even necessary, but I'll just put it there. So now, for this one here, I can simply rewrite it a little bit, and then you'll see why it will be trivial. So this one here is simply equivalent to I less than or equal to A dot upper. Okay, if you rewrite the term, A dot upper minus I larger than or equal to 0, right? If you simply move I to the right-hand side. So this is what you will get. So this is exactly what you will get. So you proved already. All right, so I'm trying to maybe just give you the essence about the proof. So your exercise will be try to present it in a way that's easy to read, right? Any question about this particular proof, if you got any question? So that's about the, I think that about enough exercises about the proof. And then I still got the remaining time. I should really try to answer other questions, as many as I can. Any question about the proof?
I have a question.
Yes, go ahead.
When we're doing the assignment device assigned to I+1, should we say old I?
Okay, sorry, which step are you talking about?
The second step.
Second step?
Saying
tell me the color. Which color?
Part.
Which color are you talking about?
Blue.
Over here?
Well, the light blue. Yeah,
the light blue.
Part.
Over here?
Yeah, so when we're doing the assignment I is assigned to I+1.
Yes.
Should we, for that second I, should we say old I?
No, okay.
Like after we're doing the replacement. So after you say A dot upper minus I, should that I be referring to the old I?
That one there, yes, you should be referring to the old I. Yes, that's correct. So you can think about when we say I is assigned to I+1. So the I here is really referring to the old I in the pre-states. So we're simply doing replacing this I, which is a post-state I, by pre-state I+1.
But you didn't explicitly say, like, in the next step, you say A dot upper minus I. You didn't say minus old I.
You mean this part here? Remember what we are calculating over here is the weakest precondition. Remember in the precondition, whenever you don't need to put any subscript. If that's what you're confused about.
Yeah, that's what I'm confused. Like, why didn't you put old I?
No, we don't need to. The reason is, I would say, let's roll back to the very beginning. I might know what you're confused about. Let's look at this. If you look at this particular postcondition over here, right? You will only run into the mix of I and I0 if you already make that such distinction in the postcondition already, but we don't. So here in the postcondition here, we simply say A dot upper minus I, and the I here is simply just a post-state value I. Agree? Up to now.
Yeah.
Good. So now that means every time if you want to replace this post-state value I by some expression. So now let's say in this case, the I+1, the I here is really referring to the pre-state value. In that case, we don't have to explicitly denote with a 0 because what we are calculating after all is really the weakest precondition. And remember, in the precondition, we don't have to really say 0 all the time.
Oh, okay. Okay, yeah, I see.
Okay. Yeah, maybe think a little bit more about it. You can feel free to put some foreign question if you still get confused. No problem.
Okay. All right, thank you.
Okay, no problem. But I think over your main confusion was why over here we don't have to say I0. It is because since we didn't really make any distinction about between I and I0 in the post condition to begin with, so we don't have to worry about that distinction.
Yeah, okay.
Okay, good. All right. Okay, from Kempe. For simplifying the WP, we should ignore else part of the if statement. No, you shouldn't ignore it. So basically what I did was I only, the pink one over here, I only did the if part over here. So what you should do is you should also say this part here should be and also AI less than or equal to R should imply the WP for R is assigned to R to establish this. That's something you should do. Okay, I just left it out. But that part should be easier to prove, I can tell you.
Professor?
Yes.
So if let's say if like this way doesn't work, we can try the other way, right? If and then else, and then we can continue.
No, actually, remember for the if branch, right? So let me just remind you very quickly. So you can think about if you got WP, you got if B, then S1. Otherwise, excuse me, give me just one moment. I move some stuff in my desk. And then S2, and then we say end. And then we got the R over here. And then what I just did was say B implies the WP for S1 to establish R. That's something I just did, okay, of course. And then what's really left out is there should be a conjunction over here, right? We want to make sure the post condition will be established in both cases, not or. So I also discuss about why having a disjunction over here would be inappropriate. So what's really left for you is to say not B also implies the WP for S2 over here to establish R. Right? That's really something you can do, you should do as an exercise to finish this particular question here.
I see. So in the exam, you should complete both of the cases.
Absolutely. Okay, another valid concern that Cedric was posting over here. He said for this particular question here, it will take about maybe 15 to 20 minutes. I think that's a reasonable estimate. So since you got 2 hours, so for every question I actually got, I thought about how much time you will require to really finish. So I think I don't have that many proof questions in the exam, so you don't have to worry. You might have just one like this, or maybe one slightly more complicated. I would say the proof question is you are expected to do it within half an hour. The complexity, it should be doable. What will we do if S2 is not specified? Yeah, exactly what I said. Over here, you can see in this case, let me highlight it. You can see this is the if statements over here without the else part. So the else part will be as if the variable is simply unchanged. That's why I simply say else R is assigned to R. You need to worry about that branch as well, because at runtime, it's definitely possible that AI larger than R is not the case. In that case, what will we do? It will be as if all the variables is simply assigned to themselves, and then we want to make sure follow any following statements, the post condition will still be satisfied, will still be established. So that's why you still got to do both branches. Okay. Andrew, are there any formal handouts about logic about final exam on the e-class for us? I would say I don't have any handouts myself, but I would say you will only be tested what I have covered, to be fair. So I would say any axioms or any lemmas or any theorems that I mentioned before, maybe in the review session or maybe in the Q&A or in the slides, they should be enough for you. Okay, that should be enough already. So maybe for your benefit, as I said yesterday, you may just want to create some data sheets for your exam. So any theorems or lemmas you think it might be useful for you, maybe for Sunday when you do the proof, you can just use it. Okay. All right, and for Nora. Can I add the estimation of time needed to solve a question in the exam? Okay, yes, I'm gonna send an announcement to, today, maybe after the recording is posted. But again, of course, that's only my estimate. Sometimes maybe some question which I believe it might take you 5 minutes, you might solve that, maybe use less time, but some question you might take more time. But it's only a reference point. So that's something I will give to you. Okay. Okay. Any more question about the proof? Okay, I still got about 20 minutes. I think at least I should cover as many as possible over here quickly. Okay, I'll try to go as many as I can. I do have many over here. Okay, but I think since you guys are suffering maybe from the proofs, so I thought it might be worth covering them. Okay, all right. So now let's take a look over here. So this one here, to be honest, I'm not exactly sure if I understand the question. So Rain, if you're here, can you just please speak up to clarify with me? So which part you're having a question about inheritance, if you're here?
Yeah, okay. So
yes.
There are a couple of things that I'm not too sure about variable assignments and casting.
Yeah.
First, is the definition correct? So variable assignment, you can assign to children only. For example, like in the purple, I put if obj is b, so at the top, obj is declared as b.
B, okay.
And then, so that means obj can be of type b and d. So
okay, let me handle this first. Okay, let me do one by one. Okay, I'm glad you're here.
Okay.
So number one, when you talk about variable assignments, let me write it out precisely as well, so your fellow student can also benefit from this. So now for variable assignments, so now let's say for this particular tree you're talking about, what's the static type for objects? B?
B,
okay,
right?
Good.
I mean, for each example, it would be different.
Okay, let's say this. Let's say, for example, if the static type is basically just B. So now let's say, if I say X is assigned to Y, it's a variable assignments. So now basically, what's the rule? The static type of Y should be a descendant class of the static type of X. Okay?
Okay.
So now when you say children, I would say it's correct but not complete. It should be descendants. In the sense that over here, you can see over here, descendants of B will be B and also D. But in general, you might just have some arbitrarily complicated subtree over here. That's also possible, right? Just descendants.
Mm-hmm.
I think that's the part you're missing. Okay, next one.
Okay, so there are 3 different situations, basically. There is the obj be right under casting. So there's an example right under casting, if you can.
Which one you're talking about?
Yeah.
Over here?
So there's 3, no, right under, to the left.
Under that, okay.
Yeah.
Casting.
So, no, it's just an example. So the example,
go ahead.
Not this one, the one over here. Obj b create obj.make. Yeah. No.
This one?
To the left, yeah.
This one here, okay.
So this is, this one is basically, obj is created as b,
okay.
And then all you do is just, what I'm understanding is variable assignment is all the descendants.
B and B, yeah, that's correct,
Okay. And the casting can be all the ascendants, so B and A.
Okay, I see what you mean. That's about the casting, right? I would say the casting, so, okay, that now I can understand better your notation here. That's good. So you're saying, can we cast OBJ to any of the descendants A and B? Okay, I would say A and B for sure, because that's really, they're simply just ancestor for static type, but let's be more precise. So here you can also potentially cast into D if the dynamic type of B happens to be D. That's also possible. So now let me just tell you about the cast, okay? Basically, what you want to know is, let's say we talk about the tree of the hierarchy for inheritance. So let's say we have some class over here. Let's say I got A here. Okay, and then I got B here. I got C here. And then I might have more classes, more ancestor. And also I might have more descendants over here. And also, let me just make it a little bit easier. We might just get a little bit more ancestor here. Okay, just arbitrarily complicated. Okay, let me also be consistent with my arrows over here. Okay, let's say that. Okay, so now let me just give you the rule over here. So let's say the OBJ is simply just A, statically. So what I would do is, it's going to be simply A over here, statically. And then what about dynamic type? Whenever you want to determine for the cast, whether or not there will be a cast exception or some violation when you do casting, you want to be careful about the expectation. So dynamic type here will be very important. Let's say for now, dynamic type is simply just over here. So we might simply say creates, and then be obj dot make. Okay, so far so good. So now what can we cast obj into? Without any runtime violation. Without any runtime violation. Okay, guys, anybody want to answer? I think the tree is general enough. So, around, so ancestor of class B. Okay, that sounds very promising. Okay, very good. Basically, we want to make sure whatever we cast the OBJ into, OBJ's current dynamic type will be able to satisfy its expectation. Okay, so that's the idea. Must be satisfiable by OBJ's dynamic type, not static type. Right? So here, if you simply say it will be the ancestor class of A, that's wrong. It's not complete. It should be the ancestor of B, including B. So you can cast all the way down to B only. But if you cast anything lower, you're going to run into a class cast exception or runtime violation. Dynamic type.
But how were you able to create it as B anyways? Because it's declared as A, so isn't that casting? Like create in curly braces B.
Yeah,
isn't that casting down?
Yeah, let me get to you in just a moment. So must be satisfied by OBJ's dynamic type. So that means ancestor of, in this case, B. Okay, so when you were talking about this particular line, we're not really doing any casting over here. We're only trying to create or reattach the objects. So now we are saying that OBJ statically is simply just A. Whatever you attach to it must be able to satisfy the expectation on A. What can that be? It can be any of the descendant classes of A. So now in this case, B is just one example. Right? So that means at the runtime, it's going to be OBJ is going to be attached to an object of type B. That's what's happening here. And now when we do casting, it's a little bit different. Think about casting is like we are trying to create an alias to the same objects. And now this alias maybe some cast variable. Let me put it here. Okay, how do we do cast? Well, of course, you got different syntax in iPhone and Java, so the idea is really the same. Let's just write it down here. So you would say check attached some type over here, and then we're going to cast OBJ as X, right? The X over here. We're creating an alias. So when you are doing casting, you're not really trying to create any new objects. You're just creating an alias. Okay, you can do something about X over here. So now for X over here, so whatever type you put over here, the green one, the orange one, whatever type you put over here is going to be the static type for X. It's like a new expectation for this particular dynamic type B. So you want to make sure if this for there to be no violation at the runtime due to casting, you want to make sure this particular X, its expectation type must be an ancestor of the dynamic type over here. So that's all the ancestor along the path. So Ray, does it make sense to you?
Yeah, so basically when we're creating, so on the constructor itself, we kind of treat it as a variable assignment where you have to.
That's correct. That's correct.
Yeah, okay.
That's correct. And when you're doing testing, it's not really like a variable assignment. You may just want to think about we are creating some alias. And that particular alias is pointing to the same objects, but it just has a different expectation. And now that expectation cannot be more specialized than the dynamic type for the objects. For example, if the casting type is actually here, in that case, there might be some expectation over here that cannot be fulfilled by B.
Okay.
Make sense to you?
Yes.
Okay, so Ring, have I answered your question here, if that's okay? Or anything else you want to ask? You're fine, right? Okay.
No, I think that's, yeah.
Okay, no problem. Okay, just want to clarify. But I think this is a little bit more general rule, so you can refer to over here. All right, so now over here, this from Daniel. So this is maybe from one of the previous quizzes. Okay, let's see this. Okay, let's see how many more I got. 1, 2, 3, 4, and 5, 6, 7. Okay, I'll see. I'll go over as many as I can. Okay, I'll try. Okay, but this one wouldn't take long. I can tell you this one is easier. Okay, Daniel was actually wondering about this particular scenario. So now we try to do clients.getF and then 2.fa, right? That's the call we are trying to make. However, somehow it is invalid. So why is that? Okay. So let me just write it out over here. So in order to see, we want to break it down into different pieces. Clients.getF. And then at index 2. And then dot FA. So now this is simply not valid, which means it wouldn't compile. So why? We don't even need to draw the inheritance hierarchy for this particular one. So that's why it's easy to see. In order to do this, if you want to analyze the dot notation over here, dot and dot, right? Let's make sure this part here is really valid. How do we know? So clients, according to your particular quiz, quiz number 8, you can look it up in your quiz. Clients is actually declared to be client number 2, right? So we want to know if getF is actually a declared routine. It is. So this part here is okay, just this part. And then simply passing integer. Statically, it's going to return some variable of type F. So now all we want to do is whether FA is really declared in F, or whether F inherits any, or whether F inherits FA from any of its ancestor. Either way. Okay, let's look at class F over here. You can see F itself simply only got FF. It does not have FA. However, is there any further ancestor of F? You can see no. F, according to the hierarchy over here, is already at the top. So there's simply no FA. So that's why FA is simply not expected on the static type of F. So that's why it wouldn't compile. Okay? Let me write down expectation over here. So FA is not declared in the ancestor of F. So Daniel, if you're here, I hope that's answered your question. So that's the specific one you were asking. Is that right?
Sir. Thank you.
Very good. Okay, glad you're here. Good. All right. Next one. This one is from Stefan. I think I already answered Stefan's question on the Google Doc. I think for the benefits for everybody, let me just briefly summarize to you what the conclusion is quickly. So somehow in the code I gave to you about observer, oh, sorry. Okay. For the observer design pattern code I gave to you in the lecture site, that one there doesn't really include the weather data. Remember we talked about weather data, right? Let me just talk about it. Okay. So remember, observer should have weather data. Should be of type weather data. That's something we talked about in the example, but I didn't really put it on the code. That's why Steven was wondering. Okay, so where the data type. So now here's the question. Should we either put the weather data attributes either in the observer class so that it is actually inherited to all the observer classes, number one. Or number two, should we actually put the weather data in the individual classes over here, right? That's a question, okay? Let me just, you can see alternative number one, we simply put weather data in this class over here, number one. Number two, we can actually put the weather data actually in each of the descendant classes over here. So either green or blue. Okay, let me just, this one should be green, just to be consistent. All right, guys, any thoughts? Which design would be better if I want to declare this weather data that's common to all the observers? So which one should I do? Should I do green or blue? Which one is a better design, basically? Anybody? Before I tell you the answer. Asma, adding into the observers class will satisfy a single choice principle. Yep, I think that's right. Because actually, I thought you can see quite clearly the way I highlighted, right? So now, if you actually put the weather data right here, it will be inherited automatically into all the descendant classes. On the other hand, if you actually put weather data, let's say in this class, also in this class separately, and also in this class separately. So that means you're declaring that in multiple places that will effectively violate single choice principle. Okay, so that's point number one. And then another, I'm going to mention one more point before I go to the next one. So now if you have the blue one, it will violate single choice principle. Okay, number one. Okay, number two. Either we go for green or we go for blue. Does it really matter from the subject's point of view? Does it really matter? Does it make a difference or does it not? And one hint for you. Look at the observer over here. This is worth thinking. Let me just rephrase the question one more time. Now we got two possible designs. Either the green, in which case we put the weather data in this class, or we got a blue design, in which case we put the weather data in every one of the effective descendant classes over here, either green or blue. So now the question is, do they make a difference as far as the subject is concerned? And the hints would be, look at the observers. Does it make a difference or does it not make a difference? Yes or no? Okay, Nora, it matters because the expectation wouldn't include the weather data in observer. Okay, very good. Yeah, I think when you explain, you gotta be, you want to be a little bit more detailed. Okay, let me just tell you, that's basically correct. You can see that observers over here, right? From the subject's point of view, basically, whenever you got observers, let's say some index I, right? Assuming that I is valid. In that case, the green one will actually be better because now observers I, in the case of green, they can expect the weather data. On the other hand, observers I in the blue design cannot get access to weather data without a cast. Okay, to be more precise for you, so now if you think about, let's say if we adopted this particular design, which means weather data is simply put over here. So that means for observers, if I simply say observers over here at position I, and then I say dot weather data. And this one here is not going to compile because the static type for observers I over here is simply observer, which according to the blue design does not include according to the blue design, does not include the weighted data in the observer. Okay, so I think for those of you who actually responded, I think you're on the right track. I just want to know how to explain it. Okay.
Sir, I have a question.
Yes.
For the observer design pattern, didn't we say that the subject should be active and the observer should be active? But if you make this relationship in the observer, doesn't that kind of declare the observer to be active?
I think not necessarily. So I think the reason that we would say in the observer pattern, the subject class will be active is only active in the following sense, to say when change happens. So when change happens on the subject side, what you will do is the subject or either subject itself or maybe somebody else, maybe let's say the subject itself is going to call notified. And then the notified is actually going to go over the list of observers and call their updates method or routine. So that's why we said it will be active. Nothing to do with what attributes we might declare in either here or here.
Okay.
Make sense to you? Okay. So guys, another question which I saw not many people got it wrong. Okay, let me just describe that verbally to you, and then you can just take a note if you wish. If you want to compare observer design versus event-driven design, right? So now you want to be very careful. Actually, let me just mention that very quickly. Okay. So now in the case, okay, I do have a diagram for the event-driven design. Okay, let's say observer. For observer design, the subject is definitely going to notify the observer directly, in the sense that if there's any updates happening in the subject side, you're going to go over each observer that's subscribed to the subject and simply call the update routine command right away. So that's why you would say that the subject will notify the observer directly, number one. Okay. What about event-driven design? Event-driven design work in a slightly indirect way in the following sense. Okay, so now if you recall this diagram from your lecture, okay, let's say we got multiple subjects and also we got multiple observers, right? Let's say we only got one event about temperature, so now we're switching to event-driven design. If there's any change happening on the subject side, right, the subject does not notify the observer directly. It does not. Apparently, you can see from the diagram. Instead, you will do it indirectly in the following way. The subject, number one, is going to publish the updates to the relevant events. And the relevant events presumably should have stored the pointer or reference to the update routine from the observer so that they can call that on the particular application or observer accordingly. Okay, so my point is, you should really know very well about the interaction pattern, the interaction scenario, whenever there's any changes happen. That's one way to distinguish between observer versus event-driven design, right? That's something I saw many of you actually selected wrong for one of your quizzes. I want to mention that. Nobody asked, but I just want to mention that to you. Okay, any more question about observer? Everybody's okay? If you don't mind, if you really got stuff to do, feel free to leave. I'm going to publish the recording later, but I might just take maybe another 10 to 15 minutes just to hopefully finish the questions briefly, right? I'll try to do it quickly, okay? All right, so this one here is from Mohammed. Okay, so now, you know what? This one is actually very similar to what I just described. Let's read it together. And guys, maybe take this as an opportunity for you to answer as a short essay question. Let's try this. Let's read it together. For the design problem of a distributed client-server system, consider the third design attempt, i.e. event-driven design, right? I just included a diagram over here for your information. When there is an update occurring in a subject or server, for example, occurring over here, and then the subject will notify all the subscribed clients observers by invoking their update commands. Now, number one, is this true or false? Okay, anybody? I saw one answer already from Amir. I want to see more answers. Is this true or false? Okay, anybody else? So far, so good. Okay, good. But hopefully, maybe if that's because maybe after I try to make the distinction between observer and event-driven design, that's good. You really listen to me. But if you knew it already, that's good. But if you're still confused, that's not a good sign. You really want to know the difference, okay? So this is false. Basically, over here, we'll notify all the subscribe client observer. This part is wrong. For event-driven design, the observers are not subscribed to the subjects directly. That's not the case. You don't have such link. Okay, and once you see the diagram, you can see. So maybe you can consider maybe putting this diagram in your data sheets. So just in case you forgot about the essence for event-driven design. Okay, so this part is wrong. And then when you say by invoking their update command, so it's not a subject which will invoke the update commands for the observer. It will be, you should really say the subject will publish the updates to the relevant events, and the events in turn is going to call the store pointers or store references for the update routines from the observers. That'll be the right way to characterize it. All right, it's a very important conceptual understanding to clarify. Okay, any question about this? Yeah, I would say, yeah, guys, I do appreciate your feeling that. So for such question, you have to read very carefully, right? So we want to really pay attention to everything. It has to be precise, and then if that's really not strictly correct, you have to say why it is not correct, right? So I would say that's a challenge. I agree. Okay. I wouldn't disagree. Okay, next one. This one is from Manor. Okay, so if Manor is here, you can also help me out a little bit, so we can also just get right to the point. Let me read the question together, okay? So what is the relationship of subscribe and also publish, and how is it ensured that the subscribe will invoke the command for the updates, okay? So Manor, if you're here, I'll try to answer briefly over here, okay? Basically, if you look at the code for event-driven design, let me just remind you the pieces you have to review. So now this part here is the observer. And this part here is the subjects. And this part here is the events. Okay, so basically number one, whenever you're trying to create a new observer, you want to make sure you subscribe the event itself or the event's update function, for example, update temperature, update humidity. So these are the update functions or update routines that's relevant to this particular observer. You want to subscribe into the relevant events, should be temperature and also humidity, right? It's a typo. So this will be the subscribing part. So now, subscription part. So now if you look at the event part over here, so now for the events, what does it really mean when you do subscribe? So that means you simply extend the new actions from that particular observer for delayed execution. You can think about this part here is really like the application is going to subscribe its update function to the events for delayed execution, which means you don't really execute the update just yet. It will only be executed if there's any update from the server side, from the subject side. Okay, so now let's say this. Whenever there is any updates from the subject side, from the subject, whenever there's anything that's really happening, for example, whenever you have set measurements over here, that means you're changing the measures from the subjects. In that case, you're just going to call the publish on the corresponding events, either temperature, humidity, or pressure, right? So when you publish, you have to pass the latest measure for temperature, humidity, or pressure, right? So now what does publish do? If you go to the publish for the events, what that will do is you simply just go over all the delayed execution references you have stored previously when the observer subscribed it into, right? And then you'll simply call that particular reference or pointers for the function, and then you will execute it. So this part I'm talking about really is whenever there is any updates from the server side, you're just going to publish the updates into the events. Publish, and then the publish part is just going to call the agent expression, basically the pointers to the update routines. That's basically what's going to happen. So Manor, if you're here, does that answer your question? Yeah, is it only one way from subject to observer? So if you look at diagram over here, right, it's consistent. So of course, when you try to publish updates, only one way, yes. So now, two parts, two different timings. When the observer is first created, you only subscribe the observer into the events. That's it. And then whenever there's any updates happening on the subject side, you're basically going to, first of all, publish to the events. And then the events will indirectly call whatever delay execution it has stored from that particular observer. It's one side, yes, only one way. Okay, so Manor, is that okay to answer your question?
Yes. In addition,
yes.
from the observer side, is it just storing the reference of the event for?
Yes, that's correct. That's correct. Yeah, let me just go there. Yes, you're right. Sorry.
Okay.
Yeah, so you can see, yeah, you're absolutely right. So if you look at the subject side over here for the weather data, you can see over here, yes, you only store the references to just the events. That's correct. You don't store a list of observers. You don't.
Okay, okay. And also, what is the importance of agent?
Agents. Okay, think about agents over here. Okay, think about without the agents. Without the agents, that means you're going to execute update temperature right here. But it's really too early, too immature for you, premature for you to actually execute this particular update function. You can think about agent over here is really like a star operator, like a referencing operator for for C language. So you can think about when this particular subjects, for this particular observer is first being created, you don't really want to update it just yet. So that's why you only try to call the agents on this update function and then store that into the events. That's that's the use for the agent expression. And then later, when you actually want to publish any updates from some subjects into the events, in that case, the event can really simply just go to the store agent expression and then call that right away for delay execution.
Okay, so just in short, it just stores the reference.
Correct. That's correct.
Okay, thank you.
All right, so Nora, do we have to study the code for this design? Number one, you don't need to study the Java code, all right? Just to alleviate some burden. That one's way too complicated. That one is really just for your study of the pattern, just to compare. However, I think for the exam, I would say it's more important to understand because it's open book exam, so you got the code available to you anyway, right? So you definitely don't have to memorize the code. But I think it's much more important to understand the interaction pattern over here, which I described. Okay, so hopefully that answers your question, I hope. All right, let me go to any more questions related to observer and event-driven design? Any more? Okay, everybody seems to be okay. All right, let me go a little bit further. Basically, okay, so I think this one here from Sabrina. Okay, should we study the design attempt in some lectures? Basically, yes. Okay, so as I also mentioned earlier in today's session, so studying the design attempt that may not be so ideal before the ultimate solution is equally important, right? So every time when I justify why those design attempts may not be ideal, so I always justify by saying what kind of design principle it violates, right? So it's really important. So I would say yes, you should really understand them as well. From Patheth. So basically just about general idea on how to justify and prove that a particular design attempt satisfies a particular design principle. Well, I would say for all the design principle over here, so I would say the way you justify, for example, single choice principle. When you justify single choice principle for, let's say, wait, I got design attempt number 1, design attempt number 2, and then all the way to the final solution, right? Each one of them is simply a separate design. You can think about the way I justify as a single choice principle for this, or for that will be just the same. Basically, the principles stay the same always. So single choice principle, for example, single choice principle simply tells you there's no duplicates. So you want to check to see whether design attempt number 1 has any duplicates, and also number 2, all the way to solution, right? I think that might be what you meant by general principle. But for definition, of course, you can look through your notes. All right, that one is just a general question. Okay, so this one is from Annis. Can I go over the visitor design pattern in detail? I would love to, but I think given a timing constraint, and also, you know, the visitor pattern lecture itself takes about 2 hours. I don't think I'm going to spend 2 hours for everybody. So I would say, Annis, if you're still here, if you can tell me which part specifically you want me to go over for visitor, I would like to. Then I'll be happy to do it. Are you here? Annis, are you here? Okay, you're still here. Good, good. So can you tell me which part of the visitor, if you still have questions, tell me which part you want me to go over? Okay, good. Okay, Annis, okay, no problem, thank you. Okay, so Annis mentioned that he already revisited the lecture, so he's not okay. Anybody, do you have any question about visitor? If no, I'm gonna move on. About visitor. Okay, if everybody's okay, so I'm just gonna move on, okay? Okay, this one is interesting, okay, from Pavel, if you're still here. So this one here, this is one of your questions for quiz number 12. Okay, Pavel, you're here, that's good. So that's the question you ask. So now for this particular one, why the looping variant is gonna occur at the end of the first iteration, okay? Let's say for this particular iteration, but Pavel, I'm gonna point right to the point for you, but you may also want to revisit part of the lecture for week number 12. That also explain in detail. Okay, but for this, I'm just gonna mention this. Basically, think about what's gonna happen here. Think about a loop counter I. Okay, so now think about different timing. Before the first iteration, and also at the end of the first iteration. Yeah, for this particular question, I'm just going to mention these 2 timings. Okay, number 1 and also number 2. Let's think about it. Okay, before the first iteration, you can see that I is simply assigned to A the lower, which is 1. Okay, and then what I need to do over here is, I think for your question over here, let's see what's going to happen. What you need to do is you want to evaluate this. Let me see over here. Did I actually copy the right question over here? Okay, so now A the lower and also I. And then this will be just 1 over here. So that means let's look at the array. So we got minus 20, we got minus 2, we got 0, we got 21, we got 48, we got 77, and also we got 99, right? That's the array. And now we got indices 1, 2, 3, 4, 5, 6, 7. Okay, so Pavel, basically what you have to do at the end of the first iteration, yeah, already running ahead, right? Okay, so that's good. I just want to explain to Pavel as well. You can see at the right before the first iteration, Pavel, let me give you some hints over here. Basically, right before the first iteration, I's value would just be 1. So you want to evaluate this particular looping variance with the value over here to be 1. I think that one is simply just going to pass because you set this to be just AI, A1. So minus 20 will just be the maximum of the array so far, right? So that one is okay. So this one will just be true. This one is not too hard, okay? And then the problem is at the end of the first iteration, we are actually going to increment the value over here for I from 1 into 2. So now I is equal to 2. So that means we are really trying to scan through this particular part. Let me just try to use different color here. So that means the looping variance is actually going to cover this part of the array, right? And then after the first iteration over here, we say if AI is larger than result, let's see what they are. Result is initialized to be A1, which is minus 20. And then A1 is also minus 20. So this is not the case. So that means the result remain to be minus 20. However, you can see over here, for the looping variance at the end of the first iteration, I will be all the way to 2. So now, minus 2 is actually the maximum, not minus 20. So this is why you will actually fail the looping variance. As Ofed also typed in the chat. Pavel, does that help you understand what's going on?
Professor, as I understand, the looping variant will be checked at the end of first iteration.
No. Looping variant will be checked. Number one, you will be checked right after the initialization step for the loop. Okay, right after, yeah, okay. You'll be checked, number one, right after the initialization, number one, and then at the end of every iteration.
I see. I think yeah.
So there,
I thought the second one, yeah.
Sure, yeah. Let me give you one reference here. So you may just want to go back to the slides. I think that there is some state chart, which I show you the timing of checking the looping variance and variance. You will see that. Okay, good. Assuming that you're okay.
Yeah, thank you so much, Professor.
No problem. Yeah, so guys, I think you definitely want to understand this kind of question to know when the looping variant might be violated, or maybe it will never be violated. It's actually quite important. All right. Okay, I got 1, 2. Okay, 2 more. Okay, I really want to complete it. Okay. But for those of you who actually put your questions on the Google Doc, we didn't get to. My apology. We just don't have enough time. Try to see if you can figure them out. Otherwise, I think most of the questions I skimmed through them on the Google Doc. I think almost all of them you can definitely find answer from the previous example we did in the class. Okay, good. So now 2 more. Okay, guys, bear with me. 2 more, and then we are done. So now number 1 over here, it's actually the same example from yesterday, but this one here is actually just different parts basically. Okay. Let me just do very quickly. Okay, basically we talk about twin. I would say I do this one first of all. Okay, we got objects over here, right? So object is of type A. So now let's say objects is simply of type A. And then we got integer I, we got object B, 0 initially, and B will also be pointing to some string. And then this will be of type B, and S is pointing to some string. Okay, doesn't matter what that string is. Okay, and then let's see the first one here. The first one here, we're basically talking about 2 different twin. Okay, the first one here, let's say the left-hand side, obj.b.twin. Okay, obj.b.twin. So basically what we will get is, so this particular object, how do we create a twin? So obj the objb.twin. Okay, so now that one there is just going to create a new B object over here, and then the string S over here is just going to point to the same string objects, right? That's a shallow copy. So this will be the twin over here. So what about another part? Another part over here is basically obj.twin. So now obj.twin, we're just moving like a slightly earlier level to do the shallow copy. So now obj is referring to this particular object here. So we're going to do obj, basically dot twin is simply just going to point to a new a object over here, but now every attribute over here is just going to be a shallow copy, right? So 0 will be 0, and b is simply pointing to the same b object over here, right? So now you can see the green and the pink, right? So now we are basically saying, let's try to see the aliasing. Let's say for the left-hand side, obj dot b, and then sorry, let me say that, do it again. Beg your pardon. Obj.b.twin is referring to this particular object. You want to go to attribute s, the string, is really referring to this particular string, right? This one here. Okay, that's a green one. And then obj.twin. So that's this pink object I just created. And then I want to go to b, which is here, and then go to b, and then go to s, is really referring to the same objects. That's why it should be true. All right, for whoever was asking this, that's true. And then the next two simply wouldn't compile. It's easy to see. It's simply because obj.b.twin. Okay, first of all, obj.b is going to be of type b. And then if you try to do twin, it will still remain to be type b. Now, is I an attribute in class b? No. Now you can see under the b, there's only string s. I is actually an attribute of type A. So that's why this is not good. Similarly, if you try to do over here, obj.b is of type B. The deep twin doesn't matter. It will still remain to be an object of type B. Does B support I? No, it doesn't. It only supports S, right? So that's why also it does not compile. All right, it's a very quick walkthrough, okay? Whoever was asking the question, are you okay with this in case you're still here? I hope. All right, let me move on. Final one. This is part of the math review, but since your fellow student asked, I'm just going to answer. Okay. So basically, this one here, we want to know what is the cardinality of the power set of this particular set over here, right? So we want to calculate, first of all, this one here, and then calculate its power set, and then calculate its cardinality, and then that'll be the answer. Let's see. If I try to do A, B, C, D, and then E, set difference with A and F, what would that be? Basically, if you calculate set difference, you're basically going to see anything that's here but not here, right? So what would that be? So that would be basically B, and then C, and then D, and then E. B, C, D, E. Agree, everybody? I hope. And then this will be the intermediate result. So this part over here is simply B, C, D, and E. So now what we want to do the next will be B, C, D, E, set difference, FG. So now, what's the element that's in here but not in here? Basically, FG and here, they're simply completely disjoint. So that means everything will be included. So that will be simply B, C, D, E. Okay, so now the entire expression over here is just going to be B, C, D, E, right? And if you want to calculate the power set, I want to mention it briefly. I'm not going to enumerate it. Think about you're simply trying to create binary number, right? Think about this will be 1, 2, 3, 4, right? So you can either have 0, 0, 0, 0. This really corresponds to empty set. If you got 0, 0, 0, 1, so this will correspond to just the set with E. If you got 0, 0, 1, 0, it's going to be D, and etc. All the way to 1, 1, 1, 1, in which case everything will be included, right? It's a very just a very something you were supposed to know, right, from the previous course. How many do we have? Basically, 2 to the power of the elements over here. So 2 to the power of 4. So you got 16. All right. Any question about this? Okay, so we are basically done with all the Google Doc questions. Okay. Okay, I think we are running much out of time. Thank you for staying. But if you want to ask any short last-minute question, I can take some before I end the recording. Anyone? Anybody? I'll wait for maybe about 1 minute just to see. If no, then I'm gonna say goodbye to you. Okay. Will I be curving the exam? That's not something I would like to commit right now. I would say do your best, and then at the end of the day, I'm gonna look at how the class perform overall for every component for the course, and then I will see what I might do. I wouldn't want to commit to anything right now. Okay. Good. Okay. Thanks for understanding. Yeah, guys, any more questions to ask? It's better to ask me now rather than emailing me, to be honest. Anything else you want to ask? Okay, I have one more tip for you, okay, for the exam. I think up to this point, you only got maybe a little bit time tonight and also tomorrow. You don't have much time. Make sure you sleep well for Saturday night because the exam is pretty early on Sunday. Make sure you wake up in time. And then I would say the best way now for you to get prepared would be you may just want to go over the quizzes, as many questions as you can, and think about what I said yesterday about for the true, false, or multiple choice questions, what might be the justification for whether one answer should be true or one answer should be false, right? That would be one way to get prepared. And also, I know it's going to be comprehensive, so you maybe just randomly go to different topics and different examples that we discussed in the course and try to review. I think the main thing you really want to get prepared for will be the essay type of questions, right? To really provide short answer and justification. Okay, Amir asked a very good question. If in case we post question on the forum, would it be answered tomorrow? Yeah, tomorrow is Saturday. I would say I cannot guarantee for very timely response, but I might be able to check maybe in the late afternoon or maybe late evening to maybe answer some questions. I will try, but I'm sorry, I cannot promise too much, but I'll try. Okay. But I think, Amir, if you really got questions related to lecture, please feel free to post on the forum. And maybe before I answer, maybe many of your good fellow students, they might just answer you anyway. I think it's only meant to be a place for you guys to help each other. That's okay. Good. I'll try. Okay. All right, guys. Thank you so much for coming, and best of luck. And then I wish you all the best after the course. And then, yeah, so as I said, I'll be in touch with you maybe after the exam. I think your exam marks may not be released before the holidays, actually, because there will be quite a good number of parts that need to be graded manually. So, but I'll be in touch. Don't worry. Okay. All right. Very good. Yeah. Nice having you. And then all the best. And then I'll talk to you later. Take care, guys. Bye-bye.
Thank you.
Thank you. Thank you. Bye-bye.